Hello friends, good evening. So welcome to our lecture 6 of chapter 1 maths. I'm Ajeet Manna, going to taught you maths lecture in English. So today our topic is Venn diagram and a few more topics we are going to discuss further. So what's the Venn diagram? Venn diagram is a visually, graphically pictorial representation of set. Okay. So in this Venn diagram, the Venn diagram is generally drawn in a rectangle, which is a universal set, and all the other sets are represented in a circular region. So in this circular region I will show you how to draw two different questions. Okay. Firstly, the universal set has 1 to 10 natural number, and the set A has 2, 6, 4, 8, 10. So we will have to write this inside element first. So 2, 4, 6, 8, 10. And after this, whatever left in the universal set, we will have to write outside the set A. Okay. So what's outside the set A? So outside we have left 1, 3, 5, 7, 9. So if we can easily see that universal set has all the elements, since the rectangle is itself a universal set and A has all the inside other elements. Okay, so we draw the first diagram. Now coming to the second illustration, we have again universal set this and set A and set B. So we will draw a rectangle here, and after that rectangle, this rectangle is actually representing the universal set and the A set. Okay, as we can see that inside the universal set we have set A, and since as we can see that 6 and 4 are already inside the set A, so the set B is completely inside the set A, and this is set B. What are the elements inside the set B? Inside the element set B, we have 4 and 6, and by removing 4 and 6 from the set A, we left 2, 8 and 10. So we will write 2, 8 and 10, and after lefting the whole set A from the universal set, we left 1, 3, 5, 7, 9. So that's how we just draw the combined effect of this. And as we can see that B is completely inside the set A, that's why B is subset of A, because B is inside set A. Coming to some basic operations of set, we are going to discuss 3 operations on set. First is union, then second is intersection, and the third is difference. Okay, so we will discuss today the operations of set, and first is the union of set. Okay, union of set, the union of two sets A and B is the set C that consists of all those elements that are either on A or in B, including both of them. Okay, for example, if I tell you in set A, that is 1, 2, 3, and another set B, that is 2, 3, 4, and we will have to write A union B. So A union B is such a set that it must be contained. A union B is a set C that must be contain A or B. Means if I will choose any element from this C set, that element must be either present in set A or present in set B. Not in both, it may be present in both, but this or this. Okay, so we will write first the element of set A and then the element of set B. But since 2 and 3 are common in this, we will don't write it again, we will just write 4. So now if we choose any element from that set C, 1 is present in set A, 2 2 is present in set B, 3 3 present in set A, 4 4 is present in set C B. So that's how we wrote A union B. A union B is such a set that all the elements from that set C must be either in A or in B. So the U we used here is read as union, A union B. Now there are some properties of a union, that is A union B is equals to B union A. That's why it is commutative. A union B and then union C it also is equals to B union C and then union A. So this is union is also associative. As we know that phi is already an element, already a part of set A, so A union phi is also A. This is known as law of identity element. So phi is the identity of U. A union A is A, so this is called idempotent law, and U union A is U. This is called law of universal set. Coming to our second operations on set, that is intersection. Intersection is basically, you can assume that the common between set A and B. Okay, so here we will use the word and, that any set, a set C is said to be intersection of set A and B if the element present in set C is both present in set A as well as present in set B. For example, if you're going to take a set 1 2 3 and another set 2 3 4, then the intersection A intersection B will be those elements which is present in set A as well as present in set B. So how many elements are there which are present in set A as well as set B? That are 2 3 2 3. So A intersection C will have 2 3. So the word and play a vital role here, that all the sets, all the elements that are present in both sets will only return in this intersection part. Here the inverted U sign is read as intersection. Intersection. Okay, so here a definition in the form of set builder form is written: X such that X belongs to A and belongs to B. If the set is present in both A and B, only then it will came into the intersection set. Okay, there are some properties which I listed as the operation of intersection. A intersection B is equals to B intersection A. So it is again commutative law. Okay, and A intersection B and then intersection C is also equals to B intersection C and then intersection to A. So it is also associative law. As you know that A is a subset of every, A is an element of every set. So A intersection phi is phi and intersection of A and U is A. So this is called law of phi and U. Phi is basically empty set. Okay, then you know that A intersection A is again A. So this is idempotent law, and if you will try to distribute it as a intersection of whole B union C will split into two parts, that is A intersection B union A intersection C. Okay, so this is called distributive law. As you know that A plus B, you just simply say this. So that's why we can also distribute union and intersection into each other. So this is called distributive law. Coming to our third property, which is difference. Difference, as you know, I will just tell you the with an example. Suppose A is 1 2 3 4 5 and B is 2 3 5, and I will say you A difference B. Then A difference B are the elements that left in set A after removing set B. Okay, A minus B is defined as a set C such that the left element in A after removing common element of common elements with B. Okay, so we will remove only those elements which are common in A and B, and the elements that left in set A is termed as A minus B, A difference B. Okay, so how many elements are common here? There are 2, 3 and 5. So how many elements left in set A? 1, 4. So 1, 4 are the elements in set A minus B or A difference B. If you are going to write B difference A, then what elements you will get? Tell me. So now you will have to note that element that are left after removing from set B. So you will have to remove all the elements common from set B and write the answers of B set. Okay. So remove 2, 3, 2, 3, and what are the elements left in the set B is 5. So B minus A is equals to 5. As you see that A minus B not equal to B minus A. So it is not commutative law, not associative law, not commutative law actually, not commutative. So as union and intersection here are commutative law, but difference is a operation that is not a commutative. Now we will solve some examples based on the today's lecture we learn. Okay, so what we learn today? We learn 4 things. First, Venn diagram. Venn diagram. Venn diagram is a pictorial representation of universal set and other sets which are inside this. Okay. Then we read operations of set. Operations on set. What are the 4 operations? What are the 3 operations you read? You read union, which is termed as A union B, or A plus B. You can say simply, no, this is actually not A plus B. I will describe it later. And then we learn intersection, and then we learn difference. So these are the 3. A intersection B is written by this, A difference B is written by this. Today we learn only 4 things, and I hope you will definitely learn, definitely grasp all this. I will also launch some revision courses based on these lectures. First I will complete all the NCERT syllabus, and after that we will continue our other courses, other lectures. Okay. So coming to this questions, in this question we will have to find A union B and A intersection B. Okay, so A union B. In A union B you write all the elements of A, 2, 4, 6, 8, and then write all the elements of B. As you already write 6, 8, you will don't write it again, so you write 10 and 12. So this is the A union B. First part is complete, and we will solve now second part. We will have to find A intersection B. In the A intersection B part, you will have to write only those elements which are common. Okay, so we will have to write only common elements in A and B. So how many elements are common actually in this set A and B? So you will find 6 is in both set, 8 is in both set. So you will just write 6 and 8. You close the bracket, and here you will get 2 answers of this question. Coming to our next example, example number 2 of this session class. This is example number 1 we solved. In this set, again you will have to find A union B and then prove that it is A. Okay. So if to find A union B, you will write all the elements of A, E, I, O, U, and after writing this all the elements of A, you will write the elements of B. But you don't write any elements twice in this set. Okay, so did we already write A? Yes, we did it. Did we already write I? Yes, we did. Did we already write U? Yes, we did it. So you do not write any other element. So this is our A union B, and it consists all the elements of A and B. But what you can see from here, you can see that these elements is actually the A set. So you will write it as A, and that's how we prove A union B is equals to A. Coming to the example number 3 today. So what are the example number 3? So they give us three various sets. They give us an set X. So that X has three elements: Ram, Geeta, and Akbar. And they are the students of class 11. Okay. Class 11 students. They are who are in school team. Okay. Then another set Y. Y is Geeta, David, and Ashok. Okay. So they are also class 11. They are also from class 11, and they are also their football team, and they are hockey team. Okay. So class 11th hockey team and class 11th football team. And we will have to find A union X union B. Okay, X union Y. So for writing X union Y, you write all the elements of X: Ram, Geeta, and Akbar. And after writing all the elements of X, you will write all the elements of Y, keeping in mind that none of the elements is repeated twice. Okay, so Geeta is already written here, so we will do not write it again. And we will, after David is not present here, so we will write David. And Asoka is also not in the X set, so we will write Asoka. So we write X union Y, and they are showing interpret the set. Interpret the sets means what? We just write the elements. Okay. Now we will have to find the X intersection Y. So we will now write X intersection Y. So what is the intersection set? Intersection set is actually the set that all the common elements. So what is the common in this? So Geeta is in both teams. So we will write Geeta. And what is your interpretation means statement? You say that Geeta plays both football and hockey from your team, from your school. Okay. Coming to our next example, what is the serial number? The serial number is 4. A is set to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and B is set 2, 3, 5, 7. We will have to find A intersection B. Okay. To find A intersection B, you will find the common element between A and B. So what are the common elements? 2, 2. So you write 2. You write Q3, 3. So we write 3. We find 5. We find 5. So we find 5. We find 7. We find 7. So we write 7. Any other elements common between them? No. So as we just find it, and what we see here, we see all the elements which we find in set A intersection B is actually present in B. So we write A intersection B is equals to B, and this is proved. Okay, coming to question example number 5, and A is a set 1, 2, 3, 4, 5, 6, and B is the set 2, 4, 6, 8. So we will have to find A difference B. and B difference A. So for A difference B, you remove all the elements that are common between A and B from A. So we cancel out 2, we cancel out 4, we cancel out 6. So what are the elements that are left in set A? For A minus B, you will write the left element of A. So the left element is 1 3 5, 1 3 5. So this is the A difference B. For finding that B difference A, you will write the elements that are left in set B after removing the common elements between A and B. So what are the elements left in set B? To find B difference A, you will write the elements left in set B. So there is only one element that is left between A and B is 8. So this is A difference B and this is B difference A. We find all the two parts they are asking. Okay, this is another example, example number 6 maybe. Yes, example number 6. We have given V is a set of vowels A, E, I, O, U. Okay, and B is another set, that is A, I, K, U. And they are saying B, V minus B, V minus B and B minus B. So we will cancel out the common elements, that is A is common, I is common, U is common. So what are the elements? For finding the V minus B, we will have to write all the elements that are left inside V. Okay, so what are the elements left inside B is E and O. So E and O is the V difference B. And what is the B difference V? We will write all the elements that left in set B after removing the common elements of V and B. Okay, so there is only one element, that is K, that left in set B. So we will write K as B difference V. So we did all the two questions that example number 6 is asking. And thanks for the wonderful journey with me. Keep supporting me and thanks for watching. See you in the next class, guys.